Okay, so last year you would have done first differences, and all you would have said is the system you're given, the relation, the function, are the first differences equal? And if they were, then it was linear. And then if they weren't equal, all you would have said was nonlinear. So this year we're going to look at, um, a little bit more specific. When is something nonlinear? So when you have there, we're going to see a recognizable pattern that is not a straight line. Last year, when you did scatter plots, you might have drawn a line of best fit, which is fine. But then and then now when we move away from lines, we're going to draw curves. So this year, we'll look at what happens when you have a squared term, is a parabola. There are cubic functions, there are x to the negative 1 or 1 over x functions. So that's what you're going to build towards. You're going to do graphs that repeat when they're called trig graphs. That's what you're going to move towards. Okay, so here we have, these are first differences. So start from the bottom. 20 minus 18 is 2. 18 minus 16 is 2. 16 minus 14 is 2, etc. So in grade 9, you may have shown the subtraction like this, or you may have just drawn these sort of symbols here and written what the first difference was. That's fine. You don't have to write 20 minus 18 or things like that. We're always doing the first differences in the y values. Because y values are, that's the dependent variable, right? So the x values you've chosen, so these should be equal by default. I'm going to go up by 1s, I'm going to go up by 5s. You don't need to calculate the differences there, unless you've made a poor graph and then things fall apart quickly, okay? Okay, so when you have differences, you can do the first differences, and then we're going to do something called the second differences this year. So you have to do the first differences first, and then you're taking the difference of the differences, okay? So first differences, again, if you want to write the math out, you can, but you don't have to. You can just write this symbol. Negative 10 minus negative 4 is negative 6. Negative 4 minus 2, negative 6. 2 minus 8, negative 6. 8 minus 14, negative 6. When you do first differences, similar to everything, just put it in your calculator, okay? If you don't want to guess, the sign matters, for example, and you don't want to make an annoying math error, okay? So first differences are equal. That's linear. Over here, 28 minus 19 is 9. 19 minus 12, 7. 12 minus 7, 5. 7 minus 4 is 3. So now the first differences aren't equal. You would have stopped there last year and called this nonlinear. Now we are going to do the second differences. So the difference of the first differences. So first differences, check if it's linear. And then now you will be able to check if it's quadratic. And then if the second differences aren't equal, then it's neither. Okay, that's a possibility as well. There are other graphs out there. Okay, so 9 minus 7, 2. 7 minus 5, 2. 5 minus 3, 2. So the second differences are equal. So it's quadratic. And you'll see once we get into the properties of a parabola, you'll see that these first differences are going to form what we call the step pattern, or how you can make your graph. Similar to what you would have done in linear, where you went rise and run, we're going to do the same, a similar sort of procedure for parabolas. So another way you can tell whether something is linear or quadratic is based on the exponent. Now, you have to make sure, like this one here, for example, that is misleading because it's not, you have to distribute that 3x, okay? Same thing here, except there's no x value there, so it's a little bit easier. So some of these are straightforward, and some of them you have to do a little bit more work, okay? So here, our x term has an exponent of 1. So again, we don't write that 1, but it's understood. So if the exponent or the degree on the x value is 1, then it's linear. If you like fancy math terms, you can write either exponent on x is 1 or the degree is 1. It means the same thing. Same thing, second one is straightforward. You just look, what's the exponent on x? It's 2. When it's 2, that means quadratic. For C, I was speaking to Mr. Todd and Mr. Yakimishin. If you had them second semester, then your polynomials and exponent unit might have been cut short, okay? So you guys have lots of space at the underneath here. I'm going to show or review how to expand that, okay? So if it was a 3, you would do the same thing. Multiply by this, multiply by this, okay? And I'm going to write it out. 3x times 2x okay? So now here, I'm going to multiply these together. So you multiply the numbers. So that's straightforward. But then if you multiply a variable X, Y, A, B, Z, M, N, whatever. And the bases are the same. So this is x1 to the power of 1, and this is x to the power of 1. What do you do with the exponents? Add them. Okay. So x times x becomes x squared, not 2x. Okay? And then the last term, I'm just going to keep it blue because there's just a number. So you just multiply 3 times 4, which is 12x. When you're adding, can this be simplified further if this is x squared and this is x? No. When you're adding, it can't. Okay, so let's write that down too, because they don't have the same base. So multiplying, you can add the exponents. If they're adding, it has to be x squared plus x squared or x plus x. Okay? But it's adding, it's not multiplying. You're doing this. See the difference? There's an add in here. I know. Okay, so when you add, they have to have the same base. Simplified. Okay, I tried to write that as simply as possible. Can't be simplified because it's adding. This is adding here. Maybe highlight that even. Okay. And the x exponent isn't the same. So we haven't even answered our question yet. Back up to C. So now, what kind of polynomial is this? Is it quadratic or linear? Yes. You look for the highest exponent, okay? So even though there's an x to the power of 1 here, that doesn't matter. This trumps that, okay? So you look for the highest exponent or the highest degree, and that tells you what kind of shape it's going to, or what kind of function it's going to be. Okay, so now when we do D, we actually don't even need to distribute it, because are we going to change anything? Are we going to change this exponent on x by multiplying by 2? No, because there's no x there. So you can if you want to, but in this equation you can see that it's going to be linear. The exponent on x is going to be 1 without distributing. Okay, so you can do first differences, then second differences to tell if something is quadratic or linear or neither. You can also look at the exponent on the x, the highest one, or the degree if you prefer. Another thing you can also look at is the shape. Okay, so here we have this shape. These are two lines, okay? That is not a parabola. This is a smooth curve. There is what we're going to call a vertex. It's symmetrical around that vertex. So there are properties of a parabola that we're going to use over and over and over again. So this one is quadratic. We're going to have parabolas that are skinny. We're going to make parabolas fat. We're going to make parabolas that open up and open down. It is not parabola, okay? It's parabola. Okay, so let's look at how to make this graph. So a skill you would have used last year is to make a table of values, and that's fine. We'll make a table of values for the two simplest parabolas, and then eventually what we're going to move towards is sort of similar to like y equals mx plus b, trying to use slope and y-intercept without making a table of values. The same thing here. We're going to use different forms of the equation in order to draw a parabola. So the first kind of equation you could be given is the one there, ax squared plus bx plus c. We call this standard form. So you're going to see that again and again. It's the standard form of the parabola, the equation, gives us certain types of information about it. We're going to do a table of values, and this is our equation here. Y equals x squared. Which is also written here in the table, okay? So negative 4 squared is 16. Remember, if your calculator doesn't put brackets, that negative sign should be inside brackets, because what we want to do is we want to get symmetry, which means the same, on both sides, right? So here, we're going to get 16. Same thing down here. If you square 4, that's 16. Negative 3 squared, 9. 3 squared, 9. Negative 2 squared, 4. 2 squared, 4. Negative 1 squared is 1. 1 squared is 1. 0 squared is 0. So this is called a basic parabola. This is like the simplest form of the equation you can get. So make your graph. There are very few negative values. That's what, if it's hard to see, this is going up to 20, okay? Like positive 20 in the y-axis. So 0, this should say x. You can kind of see it. Sorry, I'm going somewhere. One, 2, 4, 3, 9. And then do the best you can to make a smooth curve. No longer are we going to draw lines, okay? I just did a terrible job. Do better than I did. Okay, it says, number 2 says, calculate the first differences. And then what we're going to do is we're going to show that pattern on the graph, okay? So 16 minus 16 minus 9 is 7. 9 minus 4, 5. If you'd rather write them. And then it says show the pattern on the graph, okay? So we're always going to go over 1, okay? And then this is going to tell us how much to go up. So over 1, up 1, over 1, up 1, 2, 3. That's next. Over 1, up. How many should I be going? I think it's going to be 5. 1, 2, 3, 4, 5. Over 1, up. I think it's going to be 7. 1, 2, 3, 4, 5, 6. You could do the same thing on the other side. It would still be over 1, up 1, over 1, up 3, but then we're going left, right? So that's why the first differences become negative. But we will, a parabola is always symmetrical. So you could do the same thing on the other side. So this is called the step pattern. So we did a pattern in linear as well, right? We did rise and run, but we called that pattern slope. So we call this one the step pattern. It kind of looks like steps. Something else you're going to do for a parabola is talk about whether it has a maximum or minimum value. So my table of values stopped at 4. If I had an unlimited size of a grid, could I keep going? And if you look at the trend, so you guys sometimes last year would have drawn things like this, right? To indicate your line would keep going. So it's going to keep going up and up and up and up and up. Do we know where it stops? No. So it can keep going, increasing, increasing, increasing. So this value here is called the minimum. Except that's not how you spell minimum. Minimum. Now, we often short form that to min instead of max. So when we do, it almost, if you look at the next block, it almost looks like the same equation, except it's y equals negative x squared. You're going to see how that affects the parabola. And then what is this value? So here, what is the minimum? It's 0, 0. And we call that value the vertex. Yes. In a parabola that opens up, yes, and then it's going to be maximum when it opens down. Yeah? Yes. And that's next. We're going to do it. So, often when you look at parabolas, they'll ask you about what the vertex is. What's the step pattern? Is the value maximum or minimum? So we're going to do the same thing sort of over and over again. Okay? So it's hard to tell, but this is supposed to be negative x. Okay, so if that's hard to tell for you, like scratch out what I typed and write it for yourself. Okay, so now we're going to do the negative. So when you do the squaring, so then it's like negative 4 squared, but there's also a negative. And I just mixed it up here. So then that's negative 16. Same thing here. So negative 3 squared is negative 9. So we're still going to get symmetry, which was good. We want that. So this is really hard for me to read. This should be like negative 1, negative 2, negative 3. So I'm going to cheat and not do the 4, okay? So we have 0, 0. We have, I'm not going to do this one because it's not going to fit, sorry. Negative 3. 1, 2, 3, 9. even though this isn't on here, we're going to see that even if your table of values, if you have an equation, you can figure out what the step pattern is. So -7, -5, -3, -1. So when you have this pattern, similar to slope, right? If you had negative, that meant down or left. We're going to do the same thing. So we're still going to go over 1, but this time it's down 1. So -1, no big deal. Over 1, down 3, over 1, down 5. I'm just going to go back for a second to see how I wrote that. So the red's a step pattern. Okay, so this time you have to remember that it's getting more and more and more negative. So we would consider that to be smaller, right? So now this time when you have a down parabola, this is as high as it's going to get. So we call that a maximum or max. It's still 0, 0. Still called the vertex. But now it's the maximum or the biggest the parabola can get because it's going to get smaller, 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 the values. So eventually what we're going to do is we're going to talk about patterns in translating or changing a parabola. So if you have a negative, then the parabola opens down. If you have a positive in front of the x squared, it opens up. And there's summary slides on the next page. Maybe not the next page, the page after. Okay? So the graph of a quadratic relation is called a parabola. When you have the simplest parabola, so this is the like the base form, I guess. If you look, so this one is the base form, and the symmetrical axis, or the axis of symmetry, is the y-axis. And it doesn't have to be the y-axis, like this one is shifted a bit, okay? So what you're going to do, you're going to look at the x value in the vertex. So our vertex is 0, 0. So it's symmetrical about the vertex. The vertex is going to be a very important value for like the next 3 units, okay? So you're always looking, what is the maximum or minimum value? That vertex matters. So it says there the vertex is the extreme point. Sometimes we call that the optimal value, because what we're going to do when we do word problems next chapter is in chapter 5, we're going to look at when can you maximize profit, when can you minimize cost. Those are the kind of word problems we're going to look at. So there is a pattern in the y value, which we call the step pattern. So for chapter 3, we'll give you the equation and probably maybe the parabola, but you could do this with either. So this parabola goes with this equation here. So is the first term in the function positive or negative? Negative, yes. Looking at the parabola you're given, does it open up or down? Down. Okay, so if the first term, which we're going to over and over and over and over again, call that the a value, but for now, the first term is going to affect whether it's up or down. So if the first term in the a value was positive, then the parabola would open up. So the sign of the a value tells you how the parabola opens. So if you would like it even more summarized than that, if a is positive, that's up, negative, down. And really, if you think about positive and negative and like I feel positive, I feel up, you know, so. One of the things, so we're going to use standard form. We're going to use it to tell us about the a value. But something else we can do is look at this c value here, okay? So on this graph, let's see that where the graph is going to cross the y-axis. Which is at 1. To be honest, another way you could have checked, if it's hard to tell here, look over here and it crosses at 1 and that it should be symmetrical, so they should be the same. But this value here is this value here. So standard form can tell you the y-intercept. So if you are a highlighter, then I would highlight that. The c value is the y-intercept. So this slide has all of the, what's it called? The summary, okay? So when a is positive, if you enjoy mathematical terminology, that means a is greater than 0. If you don't, just look for positive and negative. Then the parabola opens up. The vertex is a minimum point because all the other values are going to be greater. The axis of symmetry is x equals 0. If it asks you to write the axis of symmetry, use the x value of the vertex, okay? And then the step pattern, this is, this is like what you do, right one, up one, whatever. We're going to write the step pattern as 1, 3, 5. You saw how big it gets, how quickly. Sometimes we'll do 7. More often you're going to get 1, 3, 5, just to make so our grids don't have to be enormous. Then if you're going down, then it's -1, -3, -5. So your break is at 10:25, okay? So you have 5 minutes at 10:25, 10:30. At 10:30, I'm going to start 3.2, but I do want to give you a chance to do this homework. This textbook is so good at this, okay? So look at these questions, try them out, and you'll notice, hopefully, that it's very similar over and over and over again. There are plenty of patterns in a parabola.